So I guess the thing that's different today compared to what you've seen in probability revision materials is that we're doing an experiment where there's a number that we get as an outcome, okay, a numerical quantity. So consider like tossing two dice. There's 36 possible outcomes if it's a six-sided die, the 1 and the 1, 1 and 2, 1 and 3, etc., all the way up. But let's say we only care about the sum of the result. Or let's say we buy a couple of electronic items, and so they could be defective or okay. So the first, they could be both defective, or we could have one defective, one acceptable, both acceptable. But all we actually care about is the number that are okay, the number that are working. So what we got there is a random variable. The result of we're doing an experiment of some sort where we get a number, and so we get a variable which is random. That's all there is to it. And I guess this is a key idea that we're going to use, we're going to build on it throughout the course, because we're going to use this idea to analyse data. So when you do any sort of study, collect some data, you're going to get some numbers. You don't know what the numbers are going to be before you collect the data. So we can treat them as a random variable, especially if we sample at random, to justify the idea of using probability to analyse the data. Formally, we could say a random variable is a real valued function defined over some sample space S, mapping from that sample space to real numbers, so that any event maps across to an X or maps across to a number. We use a capital letter to denote the random variable, so often capital X. And we could talk about the domain of variation of X, or the sample space of X. Basically, the set of all possible values that X can take is S subscript X. So when we're rolling two dice, the sample space of possible outcomes is 2, 3, 4, 5, 6, up to 12. If we're buying two electronic items and seeing the number that are acceptable, our sample space or our domain of variation is 0, 1 and 2. Now, because we're mapping from events to numbers, we can calculate probabilities for this random variable. Okay, so X equals X corresponds to a set of events, and so we can calculate a probability that X is equal to some value, little x. So for example, rolling two dice, what's the chance that the sum is equal to 2? Well, that happens if you get a 1 twice, snake eyes, and the chance of that happening for two fair six-sided dice is 1 in 36. We could say what's the probability of getting at least 11? So what's the probability that X is greater than or equal to 11? There's 3 possible events there, so it ends up being 3 on 36, or 1 on 12, for two fair six-sided dice. So we can apply rules of probability to random variables, okay? And the usual rules apply for things like that. The probability of getting a value of X that's in the set of possible events for X is equal to 1. Now, two different values of X are mutually exclusive. If X is equal to 1, then X wasn't equal to 2. And so we can sum probabilities using rules for mutually exclusive events. Probability that X is 1 or 2 is the probability that X is 1 plus the probability that X is 2. Complements, probability that X is less than X is 1 minus probability that X is bigger than or equal to X. All this stuff applies to the random variable X now. In terms of notation, there's a difference, like sometimes I'm writing big X, sometimes a little x. This is a key distinction. Big X is what we use when we're talking about a random variable. It's the name of the random variable. Little x is when we're talking about an observation. So if we're talking about height of people, height is a random variable. We could say let capital X be the height of a person. It's the height of someone that you're going to sample. And we call it capital X when we haven't done the sampling. We don't know what the value is. But then when you actually take a person, measure their height and get yourself a value, that's little x, okay? So big X is for a random variable, little x is for an observation, and that notation we'll use throughout this course. We've always got to keep in mind the distinction between when we're talking about a variable and when we're talking about the observed data. all sorts of interesting research questions can be phrased in terms of random variables. This is a framework we need to use throughout the course to analyse data, to answer questions about whether there's an effect of cloud seeding or whatever.